This airplane is expected to consume 50% less fuel than conventional airplanes. Several companies are currently working on an idea that is over 100 years old and is now making a comeback. Blended wing body airplanes. They look futuristic and are designed to make aviation more efficient and sustainable. In 2023, the US Air Force signed a $235 million contract with the startup JetZero. Meanwhile, United Airlines has announced that if the new aircraft meets all requirements, it will order up to 200 of them. So how promising is the concept? What is the physics behind it? And what do pilots say about it? That's what we look at today. So welcome to the German Science Guy. I'm Dr. Jakob Beautemps, and in Germany we say Los geht's. Today, most of our airplanes look like long tubes with wings. The tube and wing design has dominated air travel for more than 60 years now. Since the Boeing 707 in the late 1950s, the shape of aircraft has hardly changed. There are also other approaches. The flying wing design, for example. Put simply, these are airplanes without a fuselage or additional tail fins for steering. The Northrop B-2 stealth bomber is one such flying wing aircraft. However, this design is quite exotic and mainly used by the military. Another approach is a blended wing body design. This is a kind of hybrid between tube and wing and flying wing. Blended wing bodies have a fuselage, but unlike tube and wing designs, this fuselage merges seamlessly into the wings. This shape reduces drag and gives the aircraft more lift. The first versions to this design appeared almost 100 years ago. One example is the Junkers G38 from Germany. Its fuselage shape generated lift similar to that of modern blended wing bodies. However, these designs have not yet become widely accepted. The startup JetZero now wants to change this and is receiving support from the US Air Force, NASA and several US airlines. JetZero promises a 50% reduction in fuel consumption and emissions. That's how much their new blended wing body aircraft is expected to save. This would lower operating costs and is a crucial step toward achieving a net zero goal. But is such a dramatic leap in efficiency even realistic? Well, on paper, blended wing body aircrafts do have some real advantages. These range from aerodynamics and logistics to specific military benefits. But let's start at the beginning. JetZero promises 50% less fuel consumption and emissions. And indeed, research shows that blended wing body aircrafts have a significant advantage in terms of lift-to-drag ratio, so the ratio between lift and drag, thanks to the seamless transition between the fuselage and wings. Blended wing body designs perform 20% better in this point than a conventional tube and wing aircraft. This means that blended wing bodies climb more easily and can displace air more effectively, so can fly more effectively. The forces acting on the aircraft are also distributed differently. On the one hand, we are talking about inertial loads, and on the other hand, aerodynamic lift. Inertial loads are primarily related to the mass of an aircraft, but they also depend on how this mass is distributed across the aircraft and how it reacts to acceleration or flight maneuvers, for example. Aerodynamic lift, on the other hand, is generated by the airflow and causes the aircraft to rise. The big difference, however, is that in conventional aircraft, so those with a tube and wing design, these forces are distributed unevenly. Inertial loads are mainly generated at the fuselage, where most of the weight is concentrated. The lift, on the other hand, is generated at the wings. This inefficient distribution results in a particularly high load, especially at the interface between the fuselage and the wings. You've probably seen this before. Really large forces act on aircraft wings during flight. They bend quite a bit. The interface has to absorb these loads. To do this, we need really massive and heavy structural parts, which of course increase the weight of the aircraft. In blended wing body aircraft, on the other hand, the forces are distributed much more evenly. This makes the aircraft more aerodynamically and structurally efficient. The seamless transition between the wings and the fuselage also prevents stress peaks in certain areas of the aircraft. Blended wing bodies therefore require less material in these areas. In theory, the structure is a full 15 to 20% lighter than that of a conventional aircraft. Overall, blended wing body aircrafts could even save 20 to 30% in fuel consumption. JetZero even promises 50% here, but it's really worth to look at the details. These are really big numbers after all, and we will have to do this later, so we will do this in the big hurdle of this video. But let's first take a look at payload capacity and volume, because if the calculated values are achieved, there would be an improvement here that is incredible. This is also the reason why the military finds blended wing body aircraft so exciting. Today, the Air Force primarily uses Boeing KC-46 aircraft as tankers. They can transport almost 120,000 liters of fuel. Comparable blended wing body aircraft would be able to carry twice as much. The high volume is also a huge advantage if we want to fly with hydrogen. Due to their lower energy density, liquid hydrogen tanks require 3 to 4 times the volume of a kerosene tank. At the same time, a blended wing body would also enable a completely new cabin layout. 3 to 4 aisles with up to 18 seats per row are realistic here. And these aircrafts have one advantage, even if you're on the ground. This is due to the position of the engines. In blended wing body aircrafts, they are usually mounted on top. This means that the airplane shields a large part of the noise. This reduces noise pollution on the ground by 10 to 20 decibels. These are some really cool advantages that really make a difference, but if the design offers so many advantages and we've known about it for so long, why is it only now becoming a hot topic? There are a few good reasons for this. Technologically, the concept of a blended wing body was simply not feasible for a long time. It was only breakthroughs in the material science and computer-aided fluid dynamics that changed this in recent years. Startups such as JetZero are benefiting from these advantages. Although the startup was only founded in 2021, it already has numerous well-known partners and investors. These include Alaska Airlines, United Airlines, NASA, and the US Air Force. And the US Air Force alone has invested $235 million in the startup, which once again makes clear the concept of blended wing body aircrafts should definitely be taken seriously. JetZero even says at the beginning of 2027, so in exactly 1 year, the idea is set to become a reality with a 1-to-1 scale demonstrator aircraft. In other words, a blended wing body aircraft that is actually the same size as a typical commercial aircraft. In the long term, JetZero wants to pursue a 3-pronged strategy with its aircraft, focusing on passengers, cargo, and the military. However, the strategy is more military first. After all, most of the money comes from the US Air Force. And that's something we have seen in history over and over again. First military use, then commercial. GPS, for example, is a military development from the 1970s. And even canned food was first developed for the military, for Napoleon Bonaparte's troops. So yeah, actually all of this makes a lot of sense. But JetZero will definitely have to put a lot of work into the blended wing body aircraft for the US Air Force. This is mainly due to their design. And that brings us to the big hurdle of this video, which is a part in every of my videos where we take another critical look at the problems of an innovation. I do this in every video, and if you like the concept and also like that I put all my sources here in the video and then down in the description, I would love it if you subscribe and activate the bell. And if you want to, you can even be a member of this channel. You get some advantages and you support my work. That would mean a lot to me if you want to do so. Feel free to become a member to the German Science Guy. But let's start with a big hurdle because this is really important today. So if we take a look at blended wing body designs, I mean, you can see that the design is super aerodynamic, which of course provides a lot of lift and a little drag. The fact that the engines are mounted on the tail and not under the wings is actually a big advantage. I also talked about this with my YouTube colleague Pascal from AeroNewsGermany, a German aviation channel, but he's not only a YouTuber, but also a pilot, and we both find the idea behind blended wing bodies pretty exciting. And as a pilot, he naturally takes a slightly more critical view of these aerodynamic advantages. So the interview was in German, but I used AI to translate it. As many of you wrote me last time that you liked the solution for German interviews, I just wanted to let you know, so I don't hide it. And also, by the way, all the content on this channel, and also of course me talking, is no AI, so just so you know, it is all human. Just for the interview, I used AI. Okay, so what did Pascal say about the new planes?
We have already learned in the past that there are advantages to having the engines suspended under the wings. For example, when it comes to maintenance. You see, an aircraft is extremely maintenance intensive, and because the engines are positioned close to the ground, it's always easy for someone to access them. For instance, if oil needs to be refilled every single day or something similar. And for that, you simply need a ladder, not some enormous crane, just to reach the aircraft's roof at the very back.
We've learned in the past, okay, that there are some advantages to positioning the engines there, which are not to be underestimated.
And of course, when you look at it from a design perspective and see a blended wing body, you think to yourself that it's pretty much the cleanest thing you can build aerodynamically, and it does have aerodynamic advantages. but in everyday life, it would also bring some not insignificant problems.
I found this point really fascinating because, to be honest, I hadn't really thought about it before. At the same time, I noticed during my research that when you have advantages on the one side, you also have to make some compromises on the other. With blended wing bodies, for example, this applies to stability and control. At first glance, it sounds crazy to make compromises in these areas, but it makes sense to take a closer look. Blended wing body aircrafts do not have classical elevators and rudders. These stabilize conventional aircraft horizontally and vertically. Instead, blended wing body aircraft use so-called 11s. These are lots of small flaps along the wings that take over the rudder function of the tail and rudder. Rudder winglets are also a recurring feature in concepts. However, the control effect of 11s and rudder winglets is not as strong as the one of conventional tailplanes. This means, for example, that the winglet rudder turns the aircraft less to the left or right than a normal vertical stabilizer. Especially in strong crosswinds or in the event of an engine failure, this makes yaw, so this left-right movement, unstable and control is more difficult. And in fact, it doesn't stop here. During my research, I came across this study which tested the stability of blended wing bodies in a wind tunnel. Depending on how sharply the wing cut through the oncoming wind, this had a significant impact on the model. The angle at which the wings cuts through the air is also called the angle of attack. At cruising altitude, the angle for normal commercial aircraft is in the low single digits, around 2 degrees, which provides good lift with little drag. However, during a wind tunnel test, one range was particularly unstable for blended wing bodies, angles of attack from 4 to 10 degrees. Now you might think this is no problem if we fly at an angle of attack of 2 degrees. The problem is that flights are sometimes subject to strong winds. If, for example, a gust suddenly increases the angle from 2 to 4 degrees, blended wing body aircrafts tend to amplify this disturbance on their own. Instead of returning to 2 degrees, they continue to increase the angle of attack until it exceeds 10 degrees. In addition, wind tunnel data shows that if we reach an angle of 16 degrees, the situation becomes critical. From then on, it is much more difficult to control the direction of flight. This is not yet an absolute safety risk, but the angle of attack range in which blended wing bodies fly really stably are rather small. However, there are already approaches to solving the stability and control problem, for example fly-by-wire systems and AI. These supplement the pilot's mechanical controls with electronical ones. Algorithms would now respond to instabilities in real time and could then actively and dynamically correct them. Such systems already work quite well in current tube and wing aircrafts.
Even today, almost all aircraft are fly-by-wire controlled. There is no longer any mechanical connection, computers are involved anyway. And it's so sophisticated, it works so well. So in the past, it has been possible to eliminate redundant systems to such an extent or minimize the risk to such an extent that I hardly believe it would be a serious problem with such a complex design as a blended wing body.
Because fly-by-wire works so well, JetZero also wants to use such a system. Of course, that solves one problem, but it's not the only one. Pressurization is just as important. Put simply, when an aircraft flies at high altitudes, the air pressure in the cabin is greater than outside. The pressure inside wants to escape, and that is of course a huge stress test for the structure. Conventional aircrafts have two advantages here. First, because the wings and fuselage are separated, the bending loads on the wings are also separated from the pressure loads of the cabin, so they don't combine. At the same time, the fuselage of conventional aircraft is tubular, making it something like a long cylinder. Such cylindrical shapes are the optimal pressure vessel, simply because the pressure can be distributed very evenly inside them. That is why gas cartridges, for example, are cylindrical. This is a real advantage, especially for tube and wing aircrafts. This is because the pressure difference has little effect on the structure. Blended wing body aircraft, on the other hand, are more box-shaped. This means that the pressure is distributed unevenly. Since the fuselage and wings merge seamlessly, pressure and bending loads are also combined here. Without innovative reinforcements, this leads to deformation of the structure in the long term. In some cases, additional structural mass may even be required to keep the aircraft safe and stable. However, this would reduce all the efficiency advantages. And at this point, we also need to talk about JetZero's 50% fuel savings. JetZero compares its concept primarily with the Boeing 767. That is simply a 40-year-old aircraft model. They are more modern and efficient aircrafts, and more airlines are replacing the 767 with the Boeing 787 or the Airbus A330neo, for example. Of course, one should also ask, how efficient is it compared to more modern aircrafts? For example, a Boeing 787 itself consumes about 20% less fuel than the 767. If we convert that to the JetZero 50% claim, JetZero's aircraft would still save at least 37.5% in fuel consumption. Less, but still a pretty big leap. At the same time, however, JetZero is also under some pressure here. Boeing has announced a 797 model. This will probably be the modern successor to the 767 and even more efficient. And then, of course, the comparison will be exciting again. At the same time, however, JetZero must first prove in practice that their aircraft is really that efficient and also stable. As I said, extra structural material could reduce efficiency even further. Okay, however, flying is not just about efficiency. The way passengers experience flying will of course be completely different from what we are used to today. Pascal says that this is still very difficult to assess at the moment.
But it's also about how turbulence in such an aircraft will feel completely different. Flying turns will feel entirely different in such a plane, depending on how far you're seated from its center of gravity and how far you're seated to the left and right of the plane's center, right? And also the evacuation of an airplane, which is extremely important for the certification of an aircraft, will look very different, because suddenly you don't just have 5 meters forward to walk to the next emergency exit, but you might also have 15 meters sideways that you need to cover past other seats and so on. So that will be extremely important for issues that are crucial for certification, but also for the passenger experience. That is what people experience when they fly on this aircraft. If flying on this aircraft simply feels absolutely awful, to put it mildly, compared to how flying feels today, then people may simply not accept the aircraft.
Despite all these unanswered questions, JetZero already has a lot planned. As mentioned, the first 1-to-1 scale demonstrator flight is scheduled to take off in early 2027. JetZero's first production facility is now also being built in North Carolina for this purpose. The startup plans to invest a total of $4.7 billion here. The goal is to build 20 aircrafts per month. By way of comparison, in November 2025, Boeing built 45 aircrafts and Airbus built 91. 20 is significantly less, of course, but still very ambitious. And to be honest, the military-first strategy is likely to remain in place. We won't know until the 2030s whether there will also be a commercial blended wing-body aircraft in the future. Until then, we won't know whether the design will prevail this time or disappear into a drawer once again. In any case, actually, I'm very excited to see what is happening. I'd also like to know what you think about this, so please write in the comment, do you believe in the concept or should we just stick with conventional aircrafts? I always think it's nice to research about other stuff, but yeah, I'm curious to hear your opinion, and once again, thank you for all the comments you wrote under my last videos. I really appreciate it. I read them a lot and yeah, it brings me joy, and once again, thank you for that. And I say auf Wiedersehen, which means goodbye, take care, and see you again in my next video. Your Jacob.